Now we're going to use the polar form of a complex number to do one extra thing. This is not in the textbook. You generally don't see this until much later on, but it makes life a lot easier if I show it to you now. This is called Euler's formula. It's pronounced Euler's formula, but most people pronounce it Euler for some reason. And it uses a exponential function to represent cosine theta I sine theta. And it's kind of cool that you can change a sine and cosine into just a single function and have a base of e. It's kind of an amazing formula. So we're going to use this Euler's formula to convert the polar form into something that's a little bit easier to work with exponents. So the first step is I want to take this negative 2 plus 5i and raise it to the third power. So I'm going to need to take negative 2 plus 5i and convert it into polar form. So let's see, r is going to equal the square root of a squared plus b squared. So 2 squared plus 5 squared. So r is going to be the square root of 29. All right, now theta is going to equal tan inverse of negative 5 halves. It'll be b over a. And I just put a. And I always put the negative with the top number. It really doesn't matter. So 5 over negative 2, same thing as negative 5 halves. All right, now the last thing I really should concentrate on is where is this angle located? So negative 2, positive 5 would be a complex number in the second quadrant, and tan inverse only works in the first and the fourth. So I have my two choices again, and I'm going to choose the second choice this time. I'm going to choose to take my radius, stick with the angle that's going to be spit out, it's going to be this one down here, and choose my radius to be negative to end up at the right point. So in this case, I'm going to let r equal negative square root of 29, and then whatever the angle spits out of the calculator, I'm just going to use that directly. So let's see here, tan inverse of negative 5 divided by 2 is a negative 68.2. So this is approximately negative 68.2 degrees. Now I'm regretting my decision. I don't like working with negative angles either. So let's go backwards with my decision. To change this, I'll make this 180 degrees and add it on. That'll flip it around to here. So add 180 degrees. I should have done it the other way on the other one. That's 111.8. So I'll use my angle as 111.8 degrees. And I'll leave my radius alone at square root of 29. Alright, so now this becomes the modulus, square root of 29, times the cosine of 111.8 plus I sine of 111.8. And it's all going to be raised to the third power. Put it around the whole thing. That's very messy. So here's where Euler comes in handy. Euler takes a couple things. The square root of 29 is not disappearing. That would just land out front. The cosine theta plus I sine theta is going to become EI theta. So the only thing I have to note is the argument. So this is going to become bracket square root of 29 EI, and then the theta is that 111.8 degrees. Oops, I forgot my degree there. All right, and then this is going to be raised to the third power. Now the nice thing about this is, over here, it's still quite a mess, and you have to memorize a theorem to know what to do with the modulus and the argument and all that mess. Over here, on the right-hand side, after using Euler's formula, everything is law of exponents. So here you're going to take the square root of 29 and raise it to the third power, whatever the heck that's going to spit out. And then here you just have power to a power, so you take the 111.8 and multiply it by 3. So you get EI 111.8 times 3. 333, no, 335.4. 335.4 degrees. And then all you have to do is backtrack it out of Euler's formula and back into polar form. So this is going to become the square root of 29 raised to the third power. I can look it up on my calculator, but not in the mood. This will be cosine of the angle plus I sine of the angle. Oops. And then I can figure out what the heck this is equal to. Alright, so now, let's see here. This will be the square root of 29 raised to the third power times cosine of 335.4. So the first coordinate, ooh, it's a big one, would be 141.9. Well, might as well make it 142. Alright, get rid of that point. Alright, and plus, or minus, I'm not even sure yet. Let's see, this would be times sine of 335.4. Minus, yeah. So this would be minus 65i. So this is the same thing as that. They're equal to each other. So if you expanded this out, multiplied it 3 times together, you'd end up with 142 minus 65i. Alright, now that's not super important because you could sit there and multiply this out 3 times. If it was a 4th, 5th, or 6th power, then this method really becomes easier. But it also becomes easier and a lot more willing to do is if you deal with cube roots, square roots, 4th roots, and so forth.